I'm just going to show you the video because I don't think there's any
Hey guys and gals, what is good today? What is good today? How you doing? How are you doing? Welcome, welcome, welcome. Appreciate you being here. Thank you for hitting that play button. That is so awesome, awesome. Again, you guys know I love that. I love it. I love it when you show up. Showing up, here to learn, here to grow, and to become part of the 120 and above IQ club. Let's go! I love that. I love that. Thank you for the understanding of my messy intro beginning. Kind of messed that up a little bit. Yeah. I must have been all excited to get the stream going. Nothing set up properly. I thought I had it set up. Guess not. That's okay. We're here to learn. That is just the beginning stuff. So let's do this. Guys, gals, parents, here to support you. If you're homeschooling your children's, Johnny here, WhiskeyTango Sharp, coding, mathematics. I'm here to help you. Assuming that you have a lot on your plate, so here to kind of help you and relieve some of that stress. Let's go! Gonna let you know, also, sticking to mathematics over here, okay? Just to be clear, that's what's happening over here, okay? Awesome, yeah! And I fully understand and support your decision. Okay, and also, students, if you found the channel, you are also welcome. Yeah. Yes, you are. You may be searching YouTube or whatever, looking for extra additional support, and you found this channel, which is great. That is great. I love that. Thank you for finding it. Yeah. Here to help. Gonna do my best for you. Okay, I majored in mathematics. I don't want to really get into too many details, but I love math. Math is fun for me. And as you get older, I'm doing this. I'm older. I'm not even I'm done. College was long minute ago. And I'm still doing this because it's fun. It is fun. Well, I mean, I took breaks from doing it. It's not like I did it every day, but I think it's going to keep the mind fresh. That's what it's doing for this guy over here. Keeping it fresh. Lisa's trying to. Hey, yeah. And I will add, okay? Hopefully you've been following the series and following along. You probably watched the last couple of videos. We're doing these ones a little bit earlier. So I got some rest. Which is good. That's a plus. So hopefully I'm going to be paying a little more attention to what I'm doing. That's going to help, huh? Let's go. So yeah, parents, students, homeschool students that are in school. Welcome. All right. We are working on geometry. I don't know what to call this really. Grade 9, 10, mathematics. I mean, you guys learned shapes a long time ago, I imagine. Either way, we're working on some problems. The section is essentially Unit 5. We're just calling it that. Let's roll with it. And we're working on geometry. I'm going to give you guys and gals, show you my best tips, tricks, and shortcuts and tips, and give you the best advice that I can little tips and such to help you kind of memorize little things, um, solving problems, little quick shortcuts and such to make things easier and easier to understand. So that's kind of what I'm trying to do. Bear with me if I seem like I'm over explaining. I can only assume that a lot of people watching may be, they may be new. Maybe they're just learning and figuring it out, and it's all new to them. Okay. So if it seems like you already kind of know this stuff, just have some patience. Let's let the ones that are learning and still figuring it out, let's let them catch up. All right. Awesome sauceum. Let's go. All right. Remember, look in the mirror and say to yourself, I am awesome. Oh yeah, that's right, you are. Okay, where are we? We're not really going to get into any definitions or details and all that sort of thing. I think I've covered it quite enough, I hope. Let me know in comments if you want me to kind of go over something again. And also, if you have a specific area in mathematics, let me know. Yeah, I'll be glad to kind of focus on that area and do a series for you, okay? I'm kind of following a little, I don't know, the curriculum a little bit. Hopefully I am. There's obviously lots to do in mathematics, so stay tuned, have some patience, and we're going to get there, right? Okay, let's go. Time to do some math. All right, so we're going to work on this problem here, okay? Let's do some word problems, okay? These are good. These are fun, guys, okay? Flick that switch in the old brain. Click, right? Let's get ourselves ready. We're going to be doing some math now, okay? Let's go. Quick coffee? Yes. Some coffee and, excuse me, and then we're going to get going, all right? Oh, yeah. I don't know what it is. I just like doing that. Okay, here we go. A building casts 9.5 meters. I guess we could talk about meters to feet. Well, feet, inches. I guess it doesn't really matter. I know how to figure it out myself. To let you guys and gals know, I'm just going to turn this off, and then we're going to write it here. 1 meter, just a singular meter. Just think of it like a yardstick. How long is a yard? Is it exactly 3 feet? A yard? We'll find out in a sec here. So this is how long a meter is. I'm going to actually just put it in feet inches. And I believe it works out to exactly this. Okay? Those of you that understand the metric system, well, I do as well, guys, to let you know. I grew up with imperial first, okay? I'm in the north, okay? Just because I'm in the north doesn't mean I don't know how to do imperial, okay? Because that's what I learned with, okay? Metric system was kind of in school, sort of thing. All right, how long is a yardstick? And I think it's exactly 3 feet, isn't it? Yeah, it is. So obviously, if you those of you that understand the imperial system, right? Just think of a meter as a yardstick, but it's a little bit longer, right? You know how long 3 3/8 is, right? You know how long that is. So yeah, a meter is basically 3 3/8 inches longer. All right, turn that up. So that would give you kind of a good representation in your head. So if you're heading up north or whatever, and of course, you know, a lot of things are in metric. I know. So, at least you'll have kind of an understanding. Like if you see 6 meters, you'll go, oh, okay, 3'3". So yeah, it looks like 6 times 3 is 18, and of course we have 6 more 3/8, so that'd be another 18. How many? 6 times 3/8? What's that? 6 times 3/8. Let's do the long math and we'll figure it out. Oh, goodness gracious. 3/8. I have to write it slower. I guess I can reduce here. 2. We're going to take 2 out of this, so that leaves 3 and 4. So we have 9 quarters, which is 4 goes into 9 twice actually, and that leaves a quarter of an inch. There we go. 2 1/4. How did I do that, you're wondering? It's pretty easy, guys. So I took a mixed fraction, and is that how it is? Mixed. This is mixed, right? Mixed to whatever else they call it. I don't really care about the terminology as much as knowing how to do it. Basically, you go, how many times does 4 go into 9 without going over? Well, 4 times 2, right? Which equals 8. So 8 is less than 9. We haven't gone over, so I'm going to put a 2 here. Bop! How do I figure out the 1? Well, that's basically 9 take away 8. And then the denominator, that doesn't change. So it's just a matter of going and bringing it over. Essentially, it's step 1, step 2, and step 3. Just like that. Don't make it too hard, guys. Fractions it's just 2 numbers with a line in between. That's it. That's all it is. Okay. Back to our problem. Let's continue. So now 9.5 meters. So yeah, we didn't actually figure this fully out. What, 6 meters? I think it's 20 feet, if I recall. Something around there. 20 feet. Okay? We didn't quite finish, but excuse me, we got to continue. All right, 9.5 meters. A building casts a 9.5 meter shadow at the same time as a 1.5 meter tall woman casts a 1 meter shadow. Okay, 1 meter. What? Yeah, what? 1 meter being 3 foot, just like we've already determined. 3'3". And determine the height of the building to the nearest 100th of a meter. All right. Oh, okay, so it's ground level shadow. Okay, makes sense. Yeah, that's kind of realistic. If somebody could figure out how tall they are, measure how long the shadow is, measure how long the shadow is of the building. These are physical measurements you can get, actually. And then, obviously, you're not going to have a measuring tape that's going to measure the top of a building. I mean, I guess there is something out there, but it's not really a measuring tape. So, but yeah, we can do it. So let's work it out. Okay, so we have a lady, and she's this tall. Now I'm just gonna go like this, and like this, and like this, because we're not trying to draw perfect art here. There we go. And she's wearing a nice little hat. It's a summer hat. There you go. Okay. 1 meter. I'm just going to go 1 m. And her height is 1.5 meters. Okay. And then the building, okay. Oops. Trying to draw here as best as I can, guys, gals. Okay. Good enough. H is unknown. And 9.5. I know there's other ways of doing this, but for me, I'm not going to draw the windows and stuff. You guys get the idea, okay? So we need to figure out the height of the building. That's the unknown. Okay, right here. Okay, so I'm going to use ratio proportion. This is the easiest thing to use, guys and gals. I'll just write it here. Hopefully I have it enough room. If I had a tablet, I'd be able to write this quicker. Of course, I'm doing this with a mouse, guys, so I haven't had a lot of practice writing with a mouse. Bear with me and thank you for your understanding. You are awesome sauceum. Dun, 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 dun. Okay, ratio proportion. So basically I go, slope is normally y over x. So I'm going to go y over x. Y over x. It doesn't really matter how you do it, as long as you set it up properly. Y is vertical to me, x is horizontal. Okay, so I'm gonna go, so this is just a little kind of in my mind formula. We're gonna talk about slope in the future, guys and gals, so stay tuned. All right, so y is 1.5 and x is 1. And we have to make it equal. This is ratio proportion. We're going to make one side equal to the other side. So we're making the lady equal to the building. Okay, so h is unknown. That's our height. And our horizontal is 9.5. Okay, now I know, to me, guys, this is the way I teach, and this is the easiest, most simple way of doing it. Once you get it set up properly, again, you have to be consistent. Y has to be on top, x is on the bottom. You could have x on top, or it doesn't matter. You could have it reversed, but you have to be consistent in your setup. So what I mean is, y for the lady has to be on is the numerator, and y for the building is the numerator. X is the denominator, x is the denominator. You could do the opposite or flip it. It's up to you. So set up, make sure you set up properly. Okay, we got it set up. Now we could do ratio proportion. So simply just cross multiply. It's that easy. Okay, I call it cross multiplying. Just roll with it. Okay, we want the unknown variable to be on the left side. I'm consistent this way. So H, obviously, this is still 1H. We don't write 1, but H does have the value of 1. Okay? It's just imaginary 1. Get used to me saying that. I talk about imaginary 1 a lot. So now it's just this side. So it's 1.5. H equals 1.5 multiplied. Maybe I'll use parentheses times 9.5. Okay. And of course, if we had an actual denominator, let me correct myself. If we actually had a value with H, let's say it was 2, for example, we would bring it underneath, okay, as a denominator, numerator, denominator. So that would be under here. But of course, that does not exist. 1 is our value, so essentially it's going to be the same thing, except it's all going to be over 1. But we don't. There's no need or reason to write it, right? We know that H is 1. Anything divided by 1 or multiplied by 1 is the same value, right? 1 doesn't have much of a positive or a negative effect on a value, right? It doesn't create much change in a value, if you will, or any change, actually. Let's do some... Now, I know you guys and gals are like, oh, I don't want to... Yeah, no, this is good. This is good. Love this. Okay, multiplying. With decimals, right, we're multiplying here, right? All you need to do is line up the last digit, okay? Decimal position doesn't matter. For adding decimals, it does. But really, we just want to line up the last 2 values, essentially. Okay, hopefully I do this correctly. And I'll show you a little trick on how to figure out decimals. Okay, when we're multiplying. Okay, so just ignore the decimals for now. I kind of go far and above here with my teaching a little bit, okay? It doesn't hurt to kind of go over this stuff and refresh your memory. Right? Can't always rely on a calculator. 5 times 5 is 25. Carry the 2. 9 times 5 is 45. Plus 2 is 47. Now that we're going to... This is done. Now that we're going to the tens place, ones, tens, we need a... Because we're going to the tens place, we need that place filler. Okay, that's the reason for that. 1 times 5 is 5. 1 times 9 is 9. And anytime you have multiplication, you have addition. 5 and 0 is 5. 7 and 5 is 12. Carry the 1. 9 and 5, right? I usually add that extra 1 to this number. 9 and 5. Or, even smarter, is take that 1 and put it with the 9. And make the 9 10. And then add the 4. So we're at 14. Okay, so how do you figure out the decimals? It's really easy. Okay, you have to look at both values. Okay? Alright, so from here, the decimal is 1 jump. From here, the decimal is 1 jump. So we have 1 jump here. And we have 1 jump here. which gives us a total of 2 jumps. I like to play decimal hopscotch with decimals. So we got 2 jumps. We have to look at both of them. Remember, guys and gals, this one has a jump. This one has a jump. We add them together. 2 jumps. 1, 2. There's our decimal right there. That easy. That easy. Okay. Now I'm going to confirm it with my calculator, because humans do make errors. To err is human, and the greatest thing about mistakes is learning from mistakes. I love learning from mistakes because that's how you get better. 1.5 times 9.5. 14 1/4. Let's go. So now that we're done, so H is equal to 14. I guess we'll keep it in decimal value. Our accuracy, technically speaking, is going to be to the tenths place. So technically speaking, I could round this up, which would be 14.3. Our units, meters. There's our answer. I should have went like this. We round it up. I'm just gonna undo. What? Yeah, okay, that's fine. All right, I'll just leave it all. I'll just leave it. Normally I like to kind of go like this, and we'll just show it right here. Whoops. And meters, there we go. Technically speaking, we didn't need that. Okay. Do I have a way to check that answer? I don't know. That's okay. That is how that's done. And I've already given you an example how long a meter is, and really you just this works out to, in decimal value, if you want the decimal value, 3.28. Okay, so there's one video, I can't recall if it's Unit 4 series or my Unit 3 series. I show you guys how to convert a decimal to inches, feet inches. So if you check that out, I off the top of my head, I don't know which video it is, guys and gals, but it's one of those. So I recommend follow the series if you want to learn how to convert decimals to feet inches. Well, technically speaking, this is what I did here. I did this one, converted it. Okay, and that's it. And then you could, from that, you could use this and then just go, well, we could actually do it right now, but let's see, clear. I'm going to take this 14.3 and multiply it by this to get our height, and I'm going to actually use the 14.25. I'm going to multiply it by 3.28. Actually, there's a little bit more accuracy. Meters to feet. 3.28084. Okay, so I get 46.75. So that's going to be close enough, right? So you can round it to that. I know you guys know how to figure that out to feet inches. Okay. What? 46 feet. Yeah, 46 feet. That's what that is, actually. 46 feet. My bad, guys. That is 46 feet. And basically you have 3/4 of 12 inches, which is 9, right? So is that correct? Did I get that right, guys? Let me know. Okay. All right. That's good enough for that problem. Let's carry on, do some more. Almost erased it all. Whoops. What? Oh, there it is. How did I do that? Weird. That's okay. No biggie. Okay, and I really don't need this either. All right, beautiful. Okay. All right, I'm glad the commercials aren't annoying me today. Okay, what's next? What is next? All right, find the missing value X in the figure on the right. Okay, it's the same concept, guys, gals. Okay, so it doesn't matter how it's drawn, really. Essentially, we have a triangle inside a triangle. Oh yeah, let's go. Not bad. Not bad. Not bad for freehand. I wish I could lock. Like with AutoCAD, when you click in an area, you'll have like this line, and then you could actually rotate the line, and you could snap to horizontal or vertical. It's nice. And it's a nice way to draw lines quickly, but obviously I'm freehanding with a marker brush, essentially. That's okay. All right, so I'm just gonna go like this, and then we could draw a little triangle in there. Well, not a little triangle, but a little square to represent two triangles. So we have X here. We have 4 and 8. So I could go like this. I could use dimensions. It's kind of nice to see, get a nice visual. This is architectural ticks. That's what those are. You can also have arrowheads too. It just depends on the type of drawings you're doing. But I'm using architectural ticks. 4 and 8. I'm not going to draw them sideways. I'm just going to go like this. Okay, normally they would be rotated 90 degrees. And the base here is 9. And our units are centimeters. Really small. Kids, help Dad until Dad calls Mom. Our meters are here under units. This is where centimeters is. Okay, so if you want to, let's say you had, I don't know, 30 centimeters, okay? just as an example, and you wanted to know how many, if 30 centimeters, how many meters is that? How much is that in meters, right? Basically, it's just decimal hopscotch. So we know the decimal on 30 is here, right? Okay, so it's 2 jumps to meters. We're going from centimeters to meters. So we're going 2 jumps left. 1, 2. Okay? 2 jumps. 1, 2. Therefore, 30 centimeters is 0.30 meters. So basically 30% of a meter. Okay? Right? Because 0.3 is 30 100ths, right? Guys, you know this. Canceling zeros, I have 3/10. All the same. Okay, I'm going to clean this up. A little bit of review on the other stuff we've been doing. Okay, essentially we have 2 triangles here, guys, right? Guys, gals? 2 triangles. Find the missing value x on the right. Same concept. Okay, guys and gals? We're going to do the ratio proportion using the y over x concept. Get used to using y over x, because when we start working with slope, if I turn this on, it's going to be a little messy. But if we start working with slope, the slope of a line is y over x. Slope. Whoopsie doodles. That's okay. I'm just going to go like this. Equals y over x. Okay. So if we figure out a point on the line, we just got to figure out where x connects and where y connects. Okay. We'll get into that in the future. Whoops. What? There. Okay, stop. Okay. We're back. So 2 triangles. We can call this one T1, and then we have the largest one, right? We have the smaller interior one, and we have a larger exterior, if you will. Okay? And we'll call that T2. Okay? Good enough. So we're going to make T1 equal... Now this is just extra. Don't let it confuse you guys. We're just making... We got to make triangle 1. We're doing ratio proportion, right? We just need to make... Just going to go like that. Good enough. Ratio proportion. We just basically make one triangle equal the other triangle. And we're going to use y over x to do that. Okay, so let's go little triangle. Y is 4, right? This is y. This is x. I always look at y as vertical, x is horizontal. Just be consistent with that. If you start doing that now, by the time we get to slopes and such, you'll be like, yeah, this is easy. Okay? And it will be like that for you once you get to that point. Because you actually understand what's up, right? Okay, 4 over x. X is unknown. This is the easiest way to do it, I find, guys. If you're comparing similar triangles, it's the easiest. I don't know what there's other methods, but for me, this is the most simple. Okay, so we need to add this, right? So now we got to figure out the larger triangle, right? And that's this distance here, right, guys? Okay, so this is for our larger. 8 and 4 is 12, right? We know this. So there we go. Right? Sometimes you have to do, whoops, we have to do a little extra work, right? No big deal. Just got to skip a commercial here. Get skipped. And let's continue. Okay, so Y is 12 and X is 9. There we go. We're set up. I can draw beautiful clouds freehand, but not so much with the mouse. Okay, there we go. Whoops. That's our setup. Again, same thing, same concept, just cross multiply. All right. I'm going to start with the variable, right? That's what I want. I want the variable on the left side, so the variable is being multiplied by 12. Therefore, we have 12x. Make T1 equal T2. 12x times 4 times 9. So again, let's keep this simple. Again, we can divide both sides by 12. Just an extra step, that's all it is. Why not just go like this? Just bring the 12 underneath. Okay, so it's just going like this. Like that. Multiplied by 9 all over 12. I've shown you guys how to factor and reduce lots. I'm not sure how much do you want me to do a lot more. I really don't know. But I recommend you do. You might as well just get used to doing it. You're gonna have to reduce. Majority of the time you're going to have to reduce your final answer anyways, right? So you might as well save some time and just factor right now. I want to take the most meat off the bone. So I'm going to get rid of this 4 and I'm going to factor 4 out of 12. So 4 is our factorable number. What times 4 gives us 4? Well, that's 1. And then 9 is just hanging out. It's doing its own thing. Don't forget the 9. Okay, and I'm going to factor 4 out of 12. What times 4 gives us 12? That's 3. Okay. And then I'll just simplify it here so you can see it better. We're left with 9 over 3. Because these cancel. Because 4 divided by 4 equals 1. Right? Okay. Boop, boop. Hopefully I didn't mess anything up. But that's what we're left with. So 9 over 3. We can still factor, right? But I think at this point we kind of already know the answer, but I could realistically factor some more. What times 3 gives us 9? That's 3. What times 3 gives us 3? Hopefully I said that all right. That's What times 3 gives us 9? That's 3. What times 3 gives us 3? That's 1. 3 divided by, essentially we got 3 over 1. If I wanted to really show all the work, there you go. That should be our answer. 3. X is 3. Okay. I'm going to throw in the yays, just because. Why not? All right. Easy peasy lemon squeezy, isn't it? All right, how are we doing for time? You know what? That's okay. All right, let's check the stream, see how we're doing. Okay, we're kind of getting up there in time. Let's do find the missing value. This is kind of the last one on this sheet. I kind of skipped way ahead a little bit, but we'll be doing some other different type of stuff too as well, guys and gals. All right, let's just do this. You know what? I'm gonna not do this one. Just to kind of, well, we kind of did one like this. This kind of similar. We have done something similar to this, haven't we? We had 2 triangles, and we had another triangle that's kind of upside down on top of another triangle. Remember how I said you could imagine this being a pivot point and rotate this triangle upside down, like this one here. Rotate it on the peak upside down. This check mark is this check mark. If you imagine rotating it, you can see where, I know they're not the same size triangle, but you can see that this would end up here and this would end up here if we rotated it, right? You can kind of visualize that in your head, right? These are opposite angles, right? Therefore equals. Hey, hi Bishop. Welcome. Thank you for saying hi. I just noticed. Hold up, I gotta go to well, not commercial, but skip a commercial. I'm not ignoring you, my friend. It's great of you to stop by and say hello, Bishop. Hopefully you're still here. I'm about to end the stream. I do plan on doing more today. At least a couple more. It's great to have you. Welcome. To let you know, again, I'm not ignoring you guys in chats. It's just that, you know, I'm kind of focused in teaching and I'm looking at different things. I'm not really looking at chat. Plus, I have the music playing in the background, and for the most part, I have the YouTube music video tabbed up on my other monitor, and I want to be able to quickly pause it and skip channels. So, thank you for understanding. You're awesome sauce. It's great to have you. I will make sure I shout you out in comments on this video. Okay, so let's continue, and then we're gonna finish this. So you guys have this here. I'll work the problem in the next video, okay? I want you guys to kind of try this one and see if you can solve for W. Again, you guys, you could use ratio proportion. These are distances, right? We don't have any angles, okay? So take note of that, right? So for the most part, technically speaking, you could use ratio proportion with this. And looking at this now, it'll work. All right? So, yeah. try it out, and then stay tuned. Next video, I'll do the answer for you. And that's it. Appreciate you being here. Thank you guys and gals, brothers, sisters, for learning and growing. You know, if you really understood how I feel about the way of the world, we know how crazy it is. But I just love and enjoy people that kind of want to learn and expand their mind, and those that are willing to learn, especially mathematics. Like, you guys are all geniuses and intelligent people to me, as far as I'm concerned, right? And this is coming from a person that I'm country, okay? This is a country boy saying this to you. For me, math, I just love math, okay? And it's great to have those that are learning and willing to learn and willing to grow. Again, you guys are going for the 120 and above IQ club. Let's go. That's the goal. That's the dream. That's it. Johnny Whiskey Tango Sharp, coding in mathematics. I appreciate you. I will see you in the next video. Whoever you are, wherever you are, have a great rest of your day. And for now, just take care, and I'll talk to you soon. Take care for now, guys. Peace.